I'm very pleased to have been invited to give a speech on a relatively odd issue, maybe. Let's see what we can get out of it. But I have simply borrowed a text, a very common text, well known, and simply put sleep instead of love into that line. And I was also told by you, George, that there were maybe some comments to what has sleep got to do with living a good life in older age. I am, as it says here, a professor of clinical geropsychology, and gero means old. And my main position is at the University of Bergen, but I'm also an adjunct professor at the behavioral medicine department, the Faculty of Medicine in the University of Oslo. So I say this just to give you my background. And of course, I have an upbringing in my paradigms, but I've been very much, I've been fascinated by being able to be in the research group led by Marjorie Skagen. And I think I would also remind us all that that project is in fact based on multidisciplinarity. Otherwise, that project would not have money, because the whole idea is that we have to bring our visions and our perspectives together and try to find out if it gives sense. I don't know if what I'm talking about today will give you sense, but I will promise you one thing: I will try to do my best. So very briefly, my agenda is, I think it is a good thing to start with the relevance of sleep. And of course, the conference main issue is on aging, so I also want to relate it to human aging. And I say human aging because animals also sleep. And then I will bring on a word or a phrase that is very often used more and more when we talk about sleep, and that is the circadian rhythm, or the day-night rhythm. It's as easy as that, but very often referred to as the circadian rhythm. And as I say, that has to do with sleep and wakefulness. And I also want to say something about the knowledge base that we have so far and that we are working on from a medical and psychological point of view. But I also want to do one more thing, that is to take the knowledge base to practice and back again, and just give a glimpse of what I think about that. But my main issue, the underpinnings of what I'm saying to you, and I hope that I will be able to do that, that is to give my reflections on a multidisciplinary focus on this issue, because sleep is, it's so obvious that that is also a metaphor. It may be a metaphor for death, and a metaphor for maybe not having control, or from a metaphor when we see small babies sleep, we think about innocence or other words in other contexts. But sleep is also a specific phenomenon. It's very specific, and it can be measured, and it can be perceived by us as humans. So that's my agenda. Yeah, why do we sleep? And here I quote Alan Rechtschaffen, and the first quote here is from 1978. And he said, "If sleep does not serve an absolutely vital function, then it is the biggest mistake the evolutionary process ever made." That's quite a statement. And that was in November 78. And the same prominent professor, then and still, Professor Emeritus at the University of Chicago, in 2003 he said, "It may be the biggest open question in biology." And luckily I'm not a biologist, so I don't need to go into that. But I think we should start with a widened scope, simply to see how can we dig into or dive into this matter of sleep as a significant issue. And then we can zoom in and we can look at a typical 85-year-old person, typical whatever is typical. This picture, I must say, is used in very many contexts, and I think people like it because it's very illustrative in terms of sleep, and it's a kind of quietness, and it is definitely an older woman. And across a 85-year lifespan, an individual may sleep nearly 250,000 hours, or over 10,000 full days. And people often perceive time spent sleeping as lost time. And I have heard from one of my students saying, can we undo the sleep need? So, and that is also a topic, I suppose, that you will not exactly answer that question, but simply see how society more and more say that we can manipulate this sleep need. Still, the persistent internal drive to sleep and its universality across species would suggest that sleep is purposeful. And at an individual basis, I think that all of you sitting here today have a kind of conception of whether you have slept well or not during the night. Sleep and aging, then, often in gerontology, the concept of normative aging is used. We cannot go into what that is, but I assume that you will all have a kind of conception of that. Sometimes it's also replaced by normal, and let's not go into that concept either. But simply say that normative aging is associated with a reduced ability to initiate and maintain sleep. And that is a known, it's a fact. And being what is called a signature of normal aging, the neural mechanisms explaining age-related sleep impairment are actually only now beginning to be revealed. We've lots of research from both medicine, physiology, psychology, etc., into this area. But when it comes to the mechanisms of sleep, there have really been some new research from various research groups all over the world, and not least the understanding of cognitive impairment in relation to sleep problems. And one talk about sleep as a biomarker for a cognitive decline, implying that in diagnosing a person with a minimal cognitive decline, you really will, you have to look into the sleep and sleep problems related to his or her diagnosis. And in the early stages of cognitive impairment, deterioration of sleep physiology is evident, not least in the largest dementia illness disorder that we know of, called Alzheimer's disease. I will not have much graphic in my presentation. I will primarily talk from more the clinical and research area, but I think that it would be a good idea to simply bring some concepts up that will be following my presentation. And I suppose that the concept of sleep stages is used in many disciplines, actually. And we also talk about sleep architecture. That is very often used, and not least Rechtschaffen, the one that I quoted previously, uses that a lot. And what you see here is actually a very brief description of the fact that being awake, being in different sleep stages, implies that our brain waves will change. Well, is that a vital issue? It can be if we want to see whether a person objectively has slept well or not. So it's useful for the clinician, and it may also be useful for the patient, because often patients tell the doctor, for instance, that I sleep so I don't sleep at all. And when using a certain instrument to measure, it's very easy in fact, but we don't need to go into it, measuring sleep objectively, the doctor can tell whether the person has slept, how deep or light the person has slept, etc. And there is a tendency in humans, adults that is, saying that we have this tendency to underestimate how much we in fact have slept. So that seems to be part of our perception of sleep. And I will also return to the perception of sleep. So I just want to say to you that awake, but we can also be awake but drowsy, and you see that these changes are portrayed in our brain. And here we have the different stages. And this is, I cannot go into this, but this is called REM sleep, meaning rapid eye movement sleep. Somewhere in these episodes of sleep, we simply, our eyes go like this. We can see it in our cat or in our dog or in babies, or this is non-REM sleep. Here we do not have those, but when it comes to old age, we have more light sleep, stage 1 and 2, and we have less deeper sleep, stage 3 and 4, very often indicating that when we wake up with more stage 1 and 2 than stage 3 and 4, we will not feel restored. So it's as easy as that. So that's the reason why I bring up this picture. And I have one other that I want to show you as well. And that's not just sleep, but it's sleep and wakefulness across the lifespan. And this is very crude. It's not detailed in a scientific way, but it illustrates that from the very beginning of our life, and here it stops with 90. I think that was a little bit too early, if you ask me. We see there is this relative change in sleep wakefulness. So definitely we have some, you could say, sleep architecture and sleep stages tells us a lot of our sleep and can be useful for different purposes. I would also like, in the beginning of my presentation, give you some more detail what are sleep problems, because they can also be related to various other sleep illnesses, for instance, narcolepsy or different others. I will simply not mention them, but I will go to what we can see as an overt kind of proof on whether you sleep well or not. It is commonly known that older people go earlier to bed. Not everyone, and they also have early morning awakenings. And all in all, they have shorter overall sleep duration. I think I should say we have. And there is also a tendency to an increased sleep fragmentation, meaning that we sleep more in shorter periods, implying that we very often wake up and feel that I haven't slept well because I've been awake for so many times. And like I said, we have a reduced amount of deeper sleep and an increased time spent in lighter sleep. I've already said that. And also an increased time spent awake throughout the night. And if we go into frequencies of diurnal or daily naps, that increases as we age. And here you see that across the ages from 55 to 84, roughly half of these naps are unplanned. we don't plan to have them, interfering with our nocturnal, our night sleep. So there is a ratio here between night and day that may be disturbed as we age. And I must say that here we have to use the word individual differences, because many of us will not at all be affected by this. But relatively seen, many will as we age. But do older adults need less sleep? Sleep changes markedly as we transition into old age. We have established that. But there is a fundamental question that still remains debated. We don't know. Is that really so, that older adults need less sleep? What we know from, you could say more like controlled study in the laboratory, we know that younger people sleep longer than older people do if they are given the opportunity. So that is a fact in the laboratory setting. And in the same laboratory setting, we know that older individuals suffer less relative impairment on sleep-sensitive vigilance tasks, that is, demanding tasks where we have to coordinate and do things very quickly, and under sleep deprivation conditions, that is, if we ask people in the laboratory to stay awake, and that is even when they want to sleep, and that is called sleep deprivation. And sort of, older people seem to manage better, you could say the relative impairment, but when it comes to the test performance of different tasks, they will very often also fail. So this is in a controlled laboratory setting. But these observations have been perceived as being in favor of a lower sleep drive or need in older adults. I keep saying adults and adults. I know that one is English and one is American, sorry. Do older adults need more sleep, or the same kind or amount of sleep as younger? And findings in support will say that it's not a lowered sleep drive in us as we age, but maybe an impaired sensitivity to a still present drive. Something in our physiology may change to make us less sensitive to the factual sleep drive that we have. And we will see that even more in persons suffering from dementia. So current evidence remains debated, but most support the hypothesis that older adults do not have a reduced sleep need, rather an impaired ability to register and or generate that unmet sleep need. And maybe that is also related to daily naps, etc., etc. So it may be a kind of spiraling effect. So summing up this part, then, the importance of sleep for human health and performance is well established. And in meeting the demands of daily schedules in a 24-hour society, younger age groups seem to adapt better, not least in terms of cognitive performance, but sleep complaints and sleep disruptions are more common in older adults, although there are individual differences. And in dementia, sleep disturbances are often strongly accelerated, and sleep is not just physiology. Sleep is also perception and behavior. So we turn the page. And I want to introduce to you these three men. In 2017, they were so lucky to receive the Nobel Prize in Physiology or Medicine. And they are now relatively old men, but they have been working in the sleep area for decades. So when they have been recognized now, it's really a long research history underpinning that. And it is said, and I quote The Guardian from October 2017 saying, that these men, they were recognized for their discoveries explaining how plants, animals and humans adapt their biological rhythm so that it is synchronized with the Earth's revolutions. So all of a sudden it's not all of a sudden, but in my presentation, we move the sleep issue to a much larger context. In fact, we are slaves under the fact that there is a day and there is a night. And I don't think that's bad news at all. I think it really makes us humble in terms of the fact that our lives is so strongly connected to our surroundings, our physical surroundings. The very fact that we have a sun shining, and now it's shining, and in a couple of hours we know that it will shine some other place, and there will be night here. And I think that day-night metaphor, and it is also a reality for me, is I feel that I'm sort of, it's something scientific and very, very normal about that. So it really makes me think in creative ways. So that was The Guardian. And again, The Guardian, they were, this text is wonderful. I have the link, and you can find it, of course, yourself. But here comes another concept that I want to be the jungle word from my presentation today. The beauty of the body's clock is that it allows an organism to anticipate the rising and setting of the sun, rather than simply reacting to it. And for me, as a psychologist working with other disciplines, I feel this is an issue that we can talk about. The anticipation, that word anticipation may have different meanings for us, but still, I think there is a core there. It's about being human. We can anticipate the rhythm of life, and this makes it meaningful in terms of understanding both normal and abnormal aging. And I think we can use this, the anticipation, that we can perceive and understand and feel and long to the sun and feel that now we want to go to bed and rest. This rhythm is human, very human. And I think that in both medicine and psychology, we sometimes forget that because we talk about sleep, we talk about sleep problems, we talk about how can we cure you, and of course we should, because that is that we have been trained that way and we should do it. But I mean, we can sort of widen the scope and talk together on this anticipation of this rhythm. And there is another word too when we talk about, because now we talk about time as well. Do you agree? We talk about time. So keep time. I saw when I looked into, I tried to see whether American and English use that keep time in the same way. I will not go into that, but I realized there are some conceptual, maybe some nuances between the two, not two languages, but the two ways of using this language, but I will simply let that go. But keep time on our human physiology. That is what we have to do as we age as well. Do we respond well to the physiology that develops throughout our lifetime? And the biological clock, that is also a metaphor. It has another name in physiology, and I will very briefly show that to you, very briefly. But the biological clock anticipates and adapts our physiology to the different phases of the day and helps to regulate sleep patterns, feeding behavior, hormone release, blood pressure and body temperature, and our mental states as well. And you can find this at that website, so we don't need to go more into that. But I'm sorry, I lied to you. I have one more picture. And that's how the biological clock looks like when it is illustrated like this. Because this clock here is called suprachiasmatic nucleus, and is a bundle of cells somewhere in the brain. I'm very imprecise now, sorry for that. But this clock is so vital. And this clock plays together with what our eyes are exposed to, what kind of light. So we know that we can also manipulate light in order to maybe regulate this day-night rhythm. And this biological clock is also related to other organs in our body, which also have their body clocks. And when we suffer from cognitive decline or dementia, we know that this body clock is very vulnerable to being destroyed and not being able to regulate us. And that's what I've simply added in here, that sleep and circadian timing is really affected by what is called neurodegeneration seen in dementia. So it's a very vital organ. So we cannot just say that this is not important. It's very important for the understanding of sleep wakefulness and whether our eyes are able to filter the light too, because we have a yellowing of our lenses as we age that may also impair this interaction between the light outside and how it is perceived by the brain. So we know today that, and here we see clear blue sky, and here we can measure the strength and the warmth and of the light. So it's just described in a little figure there. But exposure to bright blue rich white light during the day and to softer amber light at night can help us restore the human body's natural circadian rhythm. And as we know, since we know that many of us as older persons will suffer from dementia, it is maybe a very, I would say it's a non-pharmacological way of trying to do something about this interaction between the patient with maybe a vulnerability in terms of that the body clock is not that optimal, and what can we do about it? So that is my way from, you could say, this more technical knowledge to how can I use this practically or clinically. So what we have at my faculty is what is called a human-centric lighting lab, where we have light administered through so-called LED-based bright light integrated in a standard room. And here many of my colleagues, they do various kinds of experiments. But what we have been doing is, we don't need to go into those details because you've already seen that we have this bright and we have this dim light that we can manipulate in order to mimic the day-night light. So what we can do, and what we've been doing for many years in this lab, is that we have measured various parameters related to cognition, so-called neuropsychological tests, sleep of course, pain, appetite, emotional processing, etc., etc. So these are simply some of the instruments that we use. And here you see how we can change the light in this experimental room. But when I want to translate this into a clinical practice, I just want to give you the frame that I have around that, because recent findings suggest that sleep quality plays a critical role in the preserving of cognitive function and in reducing the risk of dementia. And individuals with in particular genetic susceptibility to Alzheimer's disease. So the research on this takes place in different sleep laboratories all over the world. But my question is also, what can I do about it? In the absence of optimal pharmacological interventions, how can we strengthen our knowledge base on non-pharmacological interventions in this context on sleep? I'm not the only one asking the question. We have studies that we know of, but it hasn't been yet established, I would say. But what we do here is simply to, if you look at the last sentence here, the ceiling-mounted treatment light imitates the natural daylight by using high brightness, more blue light at midday, and less light and warmer color temperatures at dusk and dawn. So we have sort of used this kind of knowledge and taken it into a clinical unit that is a nursing home in Bergen. And this simply illustrates how we have placed this light in the ceiling. And we will also transfer this to home-dwelling people with dementia or possible dementia. So here we have 2 clinical trials going, but I will not go into that. Just say in a more general way how we can think about the new knowledge and how we can use it. And here we try to both do what we would call lab-based testing, where we can look at light and cognitive performance, and light and emotional perception. What does it do with persons emotionally? And also we can have therapy light rooms in nursing homes and at home. More what we would call field-based testing. And I now turn the page because what is so lovely to see is that we have many young people working in this area now, young people being interested in sleep and geropsychology. And I feel that as an older researcher, it's so vital for me to get young people interested in this field, really being interested from their very beginning of their career. So that is also a point taken from my part that I feel is so important in order to have many persons, many researchers going into this field. And here we also say in fact, he is he's in the government as a health minister, and he visited us recently when we introduced this study. But that is not my important issue. I just show to you that we are working on this issue. Because, and this is my last slide, I think that circadian science looking into this huge issue of daylight, physiology, perception, emotion, I think it is in this, here we have the possibility of a meeting between disciplines. I'm convinced of that. Because there is a rapid technological development of new therapies for sleep and circadian disorders, very much technology. Robots and everything, there is so much technology, but by recognizing the human need, not simply to sleep, but to, quote, anticipate the rising and the setting of the sun instead of just reacting to it, I think that we can expand our research and professional, as physicians and psychologists, narrative and our frame of reference, both as researchers and as clinicians. For me, that is a kind of paradigm that I would love to stay by. And I also think that based on what you also presented yesterday on emotions, the human emotional memory is long-lasting. We carry it with us even when we are strongly demented. And thus it can be a key to aging well in spite of our illnesses and disorders and the fact that we all shall die. Thank you.